Now we will be discussing about another topic called quicksort. Quicksort algorithm is supposed to be one of the most widely used and also proven to be the fastest in most of the use case scenario. So today we are going to discuss about what is quicksort algorithm. Okay. So let us understand about what is quicksort. So first of all, quicksort is a sorting algorithm which was developed by a great computer scientist called Tony Hoare. On an average, a quicksort makes an order of n log n, that is a big O notation time analysis, comparisons to sort n items. So time complexity is n log n. In the worst case, it makes order of n square comparisons, though this behavior is very rare. In practice, quicksort is one of the more fastest algorithm compared to any other algorithm of the same time complexity of order of n log n. So if there are other like merge sort and all, or if there is any other algorithm which is of order n log n, quicksort is still faster in most of the cases. Quicksort sequential and localized memory references work very well with a cache system. Quicksort can be implemented as an in-place sort requiring only order of log n additional space. So it can be also implemented as in-place sorting algorithm, which will save the additional space required for sorting purpose. Now let us understand a little bit how exactly this quicksort works. What is the strategy? Okay. So once we understand the basic strategy, what is exactly is the quicksort strategy? How does it work? So what we do is that let us assume that you have this pool of numbers. This is your numbers, okay? So you have 75, 57, 26, 65, 31, 43, 92, 81 and 13 and 0. You want to sort these numbers. So how you will do? First step is that select a pivot, okay? So first step is select a pivot. Now once you select the pivot, what next you do is that you try to partition all of these elements in two parts. One part is called smaller, which has all the elements which are smaller than 65, and other part which has larger than 65. So divide all the elements into two parts, one part less than 65, other part greater than 65. Okay. Once you are done with that, next is do the same thing with this one. Find out a pivot and divide into two parts. One is less than that pivot, other is greater than that pivot, and keep doing that until you reach a point where you find that the two parts are sorted on their own. Once you find them sorted, you have to merge them back. So once it comes, let us assume that you got this one, then you got this one, and then you will merge into finally this one. So let me just repeat this very simple algorithm. Quicksort algorithm, what it does is that it finds in a collection of elements, it will first find a pivot, and then it will divide all the elements into two parts. One part will be less than pivot and other part will be greater than pivot. will contain elements which are greater than pivot. So like 75, 92, 81, each one of them is greater than 65. 57, 0, 26, 31, 43, 13, all are, each one of them is smaller than 65. And this is the same process you keep doing until you reach a point where you have two arrays, each of them are sorted, and then you merge them to get a final sorted array. So that is the concept it is used here. Divide, 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 and keep doing it. Okay? Now, let us have few things here. Let us assume that you are given an array of n elements which are integers. If that array has only one element, then there is nothing to do. That every array in the world with one element is always a sorted array. If that is not the case, if the number of elements in the array are not one but more than one, then you have to do something. So what you have to do something? First is that pick one element to use as a pivot. Okay? So else pick one element to use as pivot. And then most important thing is that partition all the elements into two sub arrays, one which has less than or equal to pivot and other which is greater than an pivot. The first array will have all the elements which are less than or equal to pivot, and the second part of second sub array or the second part of the divided array will have all the elements which are greater than the pivot element. So pivot element becomes a benchmark based on which you divide it into two parts. Now once you divide it into two parts, you can recursively again call quicksort to sort those two arrays, and then after that you do the merging of sorted array when you come back. So that is what is the concept of quicksort algorithm. Now let us take one example. So we have this example 40, 20, 10, 80, 60, 50, 7, 30 and 100. So what we are going to do is that we'll pick pivot element. Now picking the pivot element itself is a topic of discussion, and there are a lot of various strategy which has been, or recommendation which has been made by people in certain scenario how to find out the pivot element. But for this course, finding out the correct pivot element and various methodology and analysis of each of those approaches to find the pivot element is not in the scope of this course. So we will not focus so much on why and which one we are selecting as a pivot, but we will just select any element as a pivot and it will still work, although the time complexity might be a little different. So what we are going to do is that we will use the first element in the array for pivot. Okay, so this is our pivot element 40. So the first stage is pick a pivot element. Now let us assume that you have selected the pivot element. What is next? Now given a pivot, we will partition the elements of the array such that the resulting array consists of one sub-array that contains element greater than or equals to pivot and other less than pivot. So let us check out. Okay. So what we will do is that we will mark this as a pivot element with a pivot index equals to 0. So what is this? These are the indexes. Okay. So let us first understand a little bit here. This is a index. Okay. So there is nothing but index. Okay. So this is index and these are the values. So these are the index, this is a value, and our pivot index is 0. So what we have done, we have selected 40 as the pivot element, and now we will start dividing this into two parts, where one part will have all the elements less than 40, less than or equal to 40, and other part which is greater than 40. How we will do that? Let us see. So the first thing we do is that we create two indexes. One is called two big index, other is called two small index, and they all starts at the extreme point here and here. Okay. Now what is the use of these two indexes? What is the use of this? Two big index, two small index. There are two indexes. This points to the first element after the pivot, and this points to the last element of this array. Okay. Now what we do is that we try to find out a index at which there is a data which is less than or equal to the pivot one. So what we do is that from here we keep moving this guy in this direction and this one in this direction. So this keep moving into this direction and this keep moving this direction, and it keep looking for a element which is greater than this 40. So he will be at 1, while data 2 big index is less than or equals to data pivot, increase 2 big index. So what is 2 big index in the beginning? 1. So data 1 is 20. What is data pivot? Is 40. 20 is less than or equals to 40. Yes, true. So move this one and keep moving until you find something which is greater than 40. Okay. Now again 10 is still less than or equal to 40, so keep moving. Now it has come 80. Is 80 less than or equals to 40? No, it is not. So now this loop will stop. So what is the next thing which will happen? It will start looking for this index, two small index, keep moving until you find something which is smaller than pivot element. Okay. Now here, is 30 smaller than pivot element? Yes, it is smaller. So what we will do? We will just stop here. And once we have stopped, the next thing what we do is that we check if this index is less than this index, then do the swapping of the element. So 30 comes here, 80 comes here. Okay. Now once the swapping is done, 30 is here, 80 is here, check is 2 small index is greater than 2 big index. Means if the gap, this one is still more, this 7 is larger than 3, yes, it is larger than 3. Then keep going as we were doing in the first. So again we will start and check, find out something which one is larger than 40. Okay. Yes, we have found one, something which is larger than 40. So now we will stop here. Now go to the next statement, keep finding something which is smaller than 40. Okay. Yes, we found it. Now again what we will do is that we will swap it, 60 and 7. Once the swapping has been done, we check, is this index, small index, is still greater than big index? Yes, it is still greater. 6 is greater than 4. Correct? Now since 6 is greater than 4, we go back to 1 again and we'll check what to do next. Is 2 big index is less than equals to data? If it is, then keep moving. So what we will do is that it comes here and it finds out that is 50 is greater than less than 40. If it is, then keep going, but it is not, so it will stop here. Now the next point, what it happens is that it goes to the small index, and a small index, it will find something which is smaller than pivot, and it will do like this. Is it smaller than this one? No, it is not. So it is greater than that one, and if it is that, then it decreases it. So keep going. Is it smaller than this? Yeah, now you have found smaller. Here it will stop. Now once this loop stops, the next statement says that if big index is less than small index. Is it less than small index? No, it is not. So this time the statement number 3 doesn't do anything. Now we will go to statement number 4, which says that 2 small index is greater than 2 big index, then go to 1. It is not. It means we are pretty much done with this whole iteration, and the final step is swap the data 2 small index with the pivot. So 2 small index is 7, and we'll swap it this element with 40. Okay, so 7 comes here and 40 comes here. Now the interesting thing you might notice, what happened in this process is that we have created 2 array, one which contains elements which are all less than 40, and the other one contains an elements which are all greater than 40. Now what is the next process? Next process is that again on this one, repeat the same algorithm 1 to 5. On this one again repeat the same algorithm 1 to 5, and you will divide into 2 parts, one containing less than or equal to, other containing greater than, and this process itself will finally lead to an array which will be sorted. Now this is what I was trying to explain, that in partition result for 40, everything which is less than or equals to data pivot is this side, everything which is greater than data pivot is this side, and this is the pivot element. So this is the result of partitioning in quicksort. And what we do is that we recursively call the quicksort on a sub arrays which was created partly because of the quick array itself. So what we have to do is that we have to see that data pivot, all the elements here are less than or equals to data pivot, all the elements here are greater than data pivot. Best case running time is n log n in the base of 2. Worst case running time is order of n square, which is not very common. Now here is the source code for quicksort, implementing your own quicksort in Java. I understand that a lot of these sorting algorithms are already ready-made available in Java, so there is no real need to implement that, but I would strongly recommend that write down this code and play around and see that if everything is fine. Now let us do the quicksort runtime analysis. The choice of pivots affects the sort's efficiency considerably in some cases. It can lead to the worst case behavior if the array is already sorted or nearly sorted. The worst case running time is order of n square. But in general or average case, the running time is n log n. That is what it says. Compared with merge sort, quicksort does not require the additional memory that merge sort needs for merging. So the benefit of using quicksort over merge sort is that it does not require additional memory.